Okay, so let's take a look at this problem. We are given here the graph of f, and it consists of these three line segments as drawn here. Tells us the function f is defined on the closed interval -5 to 4, so we're not extending our function beyond what the graph says. All right, and then we're defining this function g, so we're going to let g be the function defined by this integral. So g of x is the integral from -3 to x of f of t dt. So all of that's given to us. The question we're asked here is, on what intervals is the graph of g both increasing and concave down? So let's take a look at how to approach this. Unfortunately, we're not given the graph of g, we're given the graph of f, so we can't just examine it and answer the question. We're going to have to relate g being defined with the integral to the graph of f, and what we know about increasing and decreasing in concavity to help us determine these intervals. So let's start with where g is increasing. All right, if you recall, what it means for a graph to be increasing is the graph is rising from left to right. Okay, so if we have a graph that's rising from left to right, we can think of its slope as being positive, right? Anywhere we draw a tangent line along this curve, we get a positive slope. So we know for a graph to be increasing that the slope is positive. And if we have learned anything about derivatives, we know that that means the derivative is positive because the slope is the same thing as the derivative. Okay? So the derivative, or g prime of x, is positive as well, or we could say greater than 0, meaning the same thing. Okay? So to find out where g is increasing, we're going to look at where its derivative is greater than 0. So let's take a look at the derivative of g prime of x. Let's go up to where it was defined here in the original problem. G of x is the integral from -3 to x of f of t dt. We know from the fundamental theorem of calculus part 2 that if we want to take this derivative, it's just going to be the function itself. The fundamental theorem part 2 says the derivative of an integral, as long as the upper bound is a variable, is just the function inside the integral. Again, you can think of it as an integral undoes a derivative, vice versa. Okay, so since g prime is f, and we want g prime to be greater than 0, we also want f to be greater than 0. And since we're given the graph of f, we can just go ahead and look at it to determine where it's greater than 0. Now, graphically, this means the graph of f is above the x-axis, right? Greater than 0 would be positive again, so above the x-axis. So let's go up and look at the graph. It starts here at the point -5, 2, and it stays with a positive y value above the x-axis all the way until we get to x equals 2. So the interval is going to be from -5 to positive 2. So that's where g is increasing. All right, let's look at where g is concave down. So if we talk about concavity, for a graph to be concave down, it means it's bending down. All right, so again, if we look at the slope of this, if we go from left to right, the slope here is positive, still positive, but a little less positive. Then we flatten out to 0. Then our slope goes negative and even more negative. So we can see what's happening here is that the slope is decreasing on a concave down graph. Okay, so decreasing, if we connect that to what we talked about a minute ago up here, well, decreasing means the slope is negative. So basically the slope of the slope is negative, or we're talking two derivatives. Okay, so we're looking at the second derivative of g here has to be negative because it's decreasing, or less than 0. Okay, so the second derivative, we just go up to where we define the first derivative above, right here. And we just take another derivative. So if g prime is f, g double prime is f prime. So we're going to look at where the first derivative of f is less than 0. Okay, so again, we know the first derivative is a slope. So for the slope to be less than 0, it means the slope is negative, or the graph of f is decreasing. Okay, decreasing. All right, so again, we can just visualize that from above. If we start at this point -5, 2, again, it's decreasing. It's going down from left to right until we get to this point, x equals -3. So it's going to be on the interval -5 to -3. Then it increases until we get to x equals 0. And then from there, it's going to turn around and it's going to decrease for the duration all the way to x equals 4. So from 0 to 4 is the other interval where f is decreasing. So we've got the intervals where g is concave down and the interval where g is increasing. So to answer the question, where is it doing both, then we just look at the overlap, and it's easy to do with a picture. So if we look at that first interval, it was from -5 to 2. And then the second interval, or intervals we came up with, were from -5 to -3. And then again from, 0 to 4. So if we look at the overlap, right here is going to be where they overlap. And then right here is where they overlap. So the two intervals we're looking at are -5 to -3 and 0 to 2. So there's our answer to the question.